So today we're going to be looking at finding the perimeter and area of rectangles and parallelograms. For a lot of you this might be review, and that's okay. We just want to make sure that we touch base on all this so as we go forward you're familiar with it. Keep in mind that any side of a rectangle or parallelogram can be chosen as the base. The height is then measured along a line perpendicular to the base. So with a rectangle it's pretty straightforward. You can pick the base and then the height is any of the sides, because they're going to form that right angle. With a parallelogram, you have to remember that the height has to be perpendicular to the base or make that right angle. So we can't actually use this side as the height. Perimeter is the distance around the outside of a figure, and that's true for all figures. And to find the perimeter of a figure, we can add the lengths of all of its sides. Now, a common thing is that people mix up area and perimeter, so I like to think of perimeter as if you are making the pen around the shape, because it starts with P, so for perimeter. So it's kind of the pen, like an animal pen around the shape. So let's start by finding the perimeter of the figure. Here we just have a standard rectangle, so if the bottom is 14, the top's going to be 14. If the side is 5, the other side's going to be 5. So your perimeter is just going to be adding up all of those sides. A couple different ways that you could approach this. 14 plus 14 is going to give us 28 plus 10, so we'd have 38 units. Now it's important that you label. Here, since our numbers are not labeled, we don't know the units, we're just going to label it with units. Now one thing to be aware of is that when you're referring to the measurements of a rectangle, we often use the terms length and width. But we could also replace those with the word base and height. So the formula for the perimeter of a rectangle can be written as follows. You could have 2 times the base plus 2 times the height, or 2 times the length times 2 times the width, or 2 times the quantity of adding the length and width. So lots of different ways to do it. So let's find the perimeter of this parallelogram. Here I actually don't even have to write in all of the sides because I could use one of those formulas. So the perimeter, I like to use 2 times these two added together, so 20 plus 16. Then this becomes 2 times 36, and 2 times 36 is going to give us a quantity of 72 units. Now you could have still added up all the sides, or you could have done 2 times 20 plus 2 times 16. And that's the thing I like, is there's flexibility for however you think about it. Switching gears a little bit, area is the number of square units in a figure. A parallelogram can be cut, and the cut pieces shift to form a rectangle with the same base length and the height as the original parallelogram. So a parallelogram has the same area as a rectangle with the same base length and height. So this kind of just gives you a visual. Here we have our standard rectangle, which is 5 by 3, so it would be 15 square units. Here, even though we have a parallelogram, if you were to count all these, it would still cover 15 units squared, which is why the formula works for both. So just a hint, the formula for the area of a rectangle can also be written as area equals length times width, in place of the base times height formula that we see here. Now we want to graph a figure with the given vertices and find the area of the figure. Now obviously the figure is graphed for us already, and you can see it makes a rectangle. So what I'm going to do is I'm just going to figure out the distance for the side and the base, which we also have. So we have 5 and 3, and we want to find the area. So here, area is just going to equal our base times our height, or 3 times 5, which is going to give us 15 units squared. So just a reminder again that the height of a parallelogram is not the length of the slanted side. The height of a figure is always perpendicular to the base. Alright, so here's another one that we're going to try. Once again, the figure is graphed. Here we see 4 and 5, and you notice 4 is clearly on that dotted line. Because we're finding area, we're just going to take our base times our height, 4 times 5, and we're going to get 20 square units. Now we're going to talk about what do you do when your shape is not a standard rectangle or parallelogram. Well, finding the perimeter is simply also going to be adding up all the sides. Now the trick is here is we have a different type of shape. So what I like to sometimes do is separate my shape. So here we have a 5 by 6 rectangle, so that means this side is also 6. This one is going to be 6 by 2, and I made that because like this I know is 3 and this is 5, so the difference would be 2. But if that side's 6, then the bottom is 6, and same thing here. So all together, our bottom's going to be 18. So I'm going to go ahead and add up all those sides. So I have 5 plus 6 plus 3 plus 6 plus 3 plus 6 plus 5 plus 18. Now 5 and 5 are going to make 10. 6 and 6 is going to be 18, but 3 and 3 makes another 6. So we have 6, 12, 18, 24 plus 18. So 10 plus 24 is 34. And then we have 34 plus 18. Gives us 52. So the perimeter is going to equal 52 units. The area, which is why I separated this in the first place, is going to be adding up all these rectangles. So here we have a 5 times 6, or 30. Here we have a 6 by 2, or 12. 6 by 5 is 30 again. I can add all those together. So we have 30, 30, and 12, which is 72. So the area is equal to 72 units squared.